Ladies and gentlemen, welcome to Job Shop USA. My name is Keith and I'm your host. Today we're in here, we have a repeat customer with a repeat job, and this happens to be a repeat water jet project. The good thing is it's not the same repair on the same blade. This impeller from our wood mill customer threw another blade. All right, so this will be the third blade that's been thrown off of this impeller here. And we went through and dug up some of our information. And sometimes unconscious, you actually do keep records that are kind of pertinent to what's going on. This is my CAD program for replacing the first impeller. All right, this is the blade they threw off of here. Back, we did a video when we had our desktop WAZER, and 9/17/22 was the last repair we made. The video was called Throwing an Impeller Blade WAZER Waterjet 30-minute Replacement. So I believe in the title there, I gave my next question was, how long did it take the WAZER desktop to cut out the project? At the same time, I found the old sheet over in the corner there because we still had some area on here to cut more projects. But this is the blade assembly right here, 3 pieces. Reason why it's in 3 pieces is we want a structurally sound blade, and it has to be a weldment because you're not going to bend 60 series aluminum at a sharp 90-degree bend like that. It's just not going to happen. All right, so we have a new piece of material. That's what we're going to do. This is the blade that's broken out. And of course it was, as it broke, yeah. Okay, I'll put it in here right. Okay, so, yeah. When they come flying out, you can see that one side broke, and then they take impact, and sometimes when too big of a piece or chunk goes through this thing, this is what happens to it. All right. Before we got this the first time, this here was a repair somebody else did. The blade that we repaired is this one right here. And it still has our red dye writing on it, which came out of this dye right along this edge right here. Another thing that I had to hunt up was the rivets. Now, I have 2 long ones here, and I have little shorter ones. Even these will have to be cut down on the length, but the shank is the right diameter and the head's the right diameter. It's the same exact rivet I used on the last repair. This is the last collection here. I'll have to, if this continues, we'll see. Well, they got three out of there, and it looks like there's about 7 to 8 blades that we can manage in the future. So far, there are odds are they break out a new blade, not one that's been repaired. All right. Okay, I'm going to head on in and I'm going to create the DFX file that I'm going to have to install into the new WAM program. It's actually, the WAM has been updated and upgraded for the WAZER Pro. And I'm excited to see how much less or faster time that this is going to cut out our part for the blade here. Also, I'm enjoying submerged cutting, and this machine is way quieter than the desktop. So here we go. Let's go get it done. All right, I'm in here at my desk, and I've got you zoomed into the screen, and we're going to load our DFX into the WAM, and then we're going to create the G code for the cut file for the WAZER Pro. Now we're going to go through this, and at the end where we get everything put where we want it and all of that, we're going to go through the actual speed and the cost of cutting, or what it takes to cut this part. Versus we figured that it was about 30 minutes that the desktop cut this, because I think that was in my title, and I think I was pretty truthful on that. All right, let's go. All right, first we're just going to import the file, and it's right here. Now, I'm not going to get into WAM as far as different things that you can do, because you can split these up and reorganize them and everything else, but it is pretty much in a nice square here. So I'm going to take this, and we're going to locate this down in this area here. I knew that I was 3 squares over, about halfway, 3 squares down halfway, and we're just going to take it just a little bit inside that. I've been cutting up here on the table, and I want to kind of move some of my cut down this way here. And then of course our camera inside the chamber there is going to be a little bit closer. This is going to be a shorter cut, and I think I'm going to leave it, instead of time lapse, I'm going to leave you regular speed. All right, so that's our scale and our location there. And we're going to take metal, we're going aluminum 120. Okay, it grabs that. All right, cut paths, we're going to go outside, so it automatically puts on the outside. We're going to go tabs and lead ins, and I'm going to go with no tabs, because I know that that's what I went with on the desktop, was no tabs. And being 1/8 inch material, the little holes will probably blow out, but we're pretty sure that the pieces themselves should stay put. So we're going to leave it at that. Now we're going to hit cut. Now in cut, you have coarse, medium, and fine. And in the coarse, we're looking at almost 6 inches a minute, and the time's going to be 8 minutes and 50 seconds. You're going to use about 2.9 pounds of abrasive, and the cost is going to be about $232 to cut this part. Medium, it jumps up a little bit. It's 5 1/4 inches a minute, 9:47. Total time 3.23 pounds, and your cost jumps up to about $2.57. And in the fine is 4.5, a little bit over 4.5 inches a minute. Time total job's gonna be 10 minutes and 59 seconds. Estimated abrasive is 3.6 pounds, and you're about $2.88. Okay, so between $2.32 or $2.88. Okay, I think it's worth 50 cents more to get the fine cut. Why wouldn't you want it to be the best quality edge that you could possibly get? All right, so we're going to go ahead and we're going to generate that code right now, and find the right file here. Okay, here we go. All right, now we're gonna call this fan blade. All right, save. All right, that's already being sent. So we should be good to go. Let's eject that. All right, we got our file here. Let's go. All right, just to wipe down with our microfiber, wanted to kind of touch bases with you or give you an update. Now we've only done 3 projects, 4 projects in here. Between submerged cutting and we coated this with ceramic inside, outside, everywhere we felt that it was going to need protection. And it's holding up pretty good and it wipes off pretty easy. And I don't notice scratching, but it's still young, like the lens in a sandblast cabinet. All right, who knows? Anyway, look how it's looking. It's looking pretty good to me. All right, so it's holding up, and I have a clearer screen on this Pro. Probably a little easier to clean up as well as the desktop. All right, we're ready to put in our card, turn on our machine, and check all of our functions and get ready to make a cut here. We're inside this screw over here, but we've already set this around where we want it for our height and everything else. We've been pre-testing and leveling that. So we're going to go select cut file. Scroll down here to fan blade. Yes. Lip nozzle, we already know we're close. Okay, it's going to come down to the start of that area. All right. We already filled the hopper. Confirm the water's on. Fasten material to bed. Lift nozzle. Okay, we're going to, instead of cutting material, we're going to go for a dry run. It's a good idea just to make sure that so it's going to cut the long bar first. Cut the small one. And it's going to cut the center of the blade. All right, cool. Now we're ready to go for a cut. We're all set on the sand, abrasive, camera's on. I think we're ready to rock and roll. There it goes. And it's already pierced that fast. It went through that 1/8 of an inch material. It's gonna be pretty cool. Okay, we're gonna let that cut. to shut off my little camera here. Okay, and we'll get that out of the way here. All right. Drain down the water. A lot easier. This piece actually flew out. It was, I looked at it. I was kind of worried about this one here. This was the pierce point right here, and the blast lifted this one here. If we manually put the pierce over here and then had it go around this way right here, they probably would have all stayed in here. But that's where you got to decide whether you're going to put a tab on or not. Yeah, I like that. That tank drained right down. Nice. All right. Here's the deal. That's some clean cutting and fast. All right, let's dry them off and head on over to fabrication bench. We got our pieces here. Let's prepare them for welding. Okay, we're not going to worry about these holes because what we do is we run a reamer through them because they're slightly smaller than this now, and these are slightly smaller than this now. So when we get this welded and fabricated, then we hold it up and we run the reamer through the holes in place and set each rivet one at a time. All right, that's all it took to prep those for weld, minus wiping down with acetone. I got to remove the heads of these rivets. I marked them on this side here after I double checked this like 3 times. You want to make sure you're taking the right ones off. Now I'm going to take and grind this off of here. Let's see if you want to hang around and listen to this or not. After I took it down with the hard stone, you get down close. You don't want to take off as much of the base material because this is supposed to be a balanced part, which the customer is responsible to send it out and have it balanced after the fact. You can't do something with a impeller, propeller, and everything else that have full assurance of vibration without sending out for balancing. All right. Now we just need to punch those out. Let's see how these punch out here. I've got a slightly smaller punch than the diameter. All right, they're moving. Okay. Here's our pieces here. All right, and that's the size rivet. If we take this piece in here, we're going to move it slightly over the side because we want to set it up on there because this is 100% penetration. So this part is actually going to be setting up the thickness of that 1/8 of an inch here. And you see that we still have a good clearance in here. Okay. And here again, this piece will be like right here. So you can see that we have quite a bit of area right here that we have to bend that lip down so that this surface right here is uniform all the way around as it spins. Each time that these have ripped up, we've had to fix that. And I know that the original one that was broke out before we even started to replace this one over here, we could see that they had the same type of thing. Had to be bent back down again. All right, we're gonna work on straightening this out, and then we're gonna set up and weld our piece together. Looking pretty good. I think once we get that piece in there too, and we hold this piece down a little bit, we're gonna get a better alignment. But it's looking pretty good. All right, I think we're gonna leave it like that until we make the piece. That looks pretty darn good. Okay, all right. There we go. Nice, good, full penetration corner bead. This little vise here helped me out a lot on setting up things like this, and having it set up exactly like this, we're gonna have a good well bead going right in on there. I just want a nice sharp edge there when I sand this weld down to make a nice radius, like the original was curved. Let's check it out here. I sanded and dressed off the outside of this. We're gonna put a well bead here, but I gotta downsize my tungsten and my tip size to get a nice bead in there without flowing out over these holes. This was a 1/8 tungsten I was using to weld this out here, and it was heavy, but look at I got the material in there and I got my results I needed to have. All right, so let's check this out. We're gonna put this in here, and those holes on the bottom are lined up, and we pull this over a little bit, line those up there. All right, I'm happy. We're gonna go ahead and set up and do our inside welds now. And I'm set up here. I'm not even gonna try to get you in to look at this here, because this is hard enough without any other effort. And an inside little tiny bead, just trying to get it in there. I'll show you the results when I get done. And I just got comfortable. I got a board here, so I'm in the exact right purpose. This little tool I have here gets me set up pretty good. All right, I'm gonna give it a shot here. No burn through. Got close to the holes, but I just take a little rotary burr, I'll dress up the flat, making sure that rivets will fit right in there. We assembled our fin in here with 1/4 20 bolts just to tension it up into spot. And then we ran our reamer through these 2 holes here, and then we tapped in rivets from this side here. Now we're ready to go in and actually peen those rivets into place. Then we'll pull out our fasteners one at a time and replace those. I just fired up the press and brought my ram down, and it's stacked up so that I have one of my 3-inch bars sticking out here like an anvil, because that's what we really need. We just need something solid underneath the head of the rivet so that we can peen the back side here. And we're going to take and slip this right here, and those rivets are taller than the 1/4-inch heads of the 1/4 20s. See, I can tip that to touch that one, tip it back here to touch that one. All right, and we're going to put that reach over, that pickup. All right, and we're going to reach in here. All right, we got that locked in there. We're just verifying, and that looks good. We do need to come out a little bit here because I can actually see that we're sitting on the center hub here. Okay, we're off of that hub. We're solid on these 2 rivets right here. All right, my favorite peener. All right, let's go ahead and we'll pull out the next ones and install the next set that we're going to hammer. They're looking good in here. All right, we got the 2 on the back plate here, and the cowling on the front here, we're putting the pressure underneath this rivet here. The bolt is still in this one here. This is just spacing up the bolt so that we get it really positively leaning there. This is to hold the fin on there so I don't have to hold this thing up in the air. And this clamp had to be put in here because I want to make sure that there is no expansion in between there and we're solid. And this actually has like a slight curve to it, and the air will bend up and it will take shape here. And I'm going to use my small drift here to go ahead and do the mushrooming on each side here. Okay, that's down nice and tight. I'm going to take this off of here so that I can hit it from this direction right here. All right, that one's set in there nice. Now we'll remove and ream this one, and it'll be the last rivet we have to put in here. Let's see if we can get you to see inside there. There we go. our customer's fan is ready to go back in action, and he's in a pretty much of a hurry for it. He kind of let us know that he was when he left this off. We had a few other projects going on in the shop, so I decided to do this. Happy Labor Day. This is my Labor Day project, hence being a little more casual. Anyhow, we got to play with WAZER Pro, and we learned how much faster it is and how nice that cut looked. And I kind of followed up with a project we've had in here before and proving that our repairs are holding up and other things are failing. And I counted the fins. It's nine more to go to have them completely replaced. But I always do like a challenge. Second time around, still in good shape. Awesome. All right. Thanks for visiting Job Shop USA. Until next time, get her done.